All right, so I'm going to go ahead and just do all of these on one video, I think. A 0.530 kilogram basketball hits a wall head on, okay, with a speed of 18 meters per second. Okay, so I'm going to say this way is positive. It rebounds with a speed of negative 13.5. Okay, and so I've very nicely given you the negative because see how it's going the other way now. So you have to make sure you plug in that as negative. Okay. And it's going to do that in only 0.1 seconds. Okay, what's the force on the wall? All right, so it's not a bad idea to make a list. Okay, so my initial velocity was positive 18. My final velocity, negative 13.5. Okay, the time is 0.01 seconds, and I'm looking for the force. Okay, so pretty much this is the equation that we're using. All right, so I'm just going to go ahead and write it first. It's always good practice to write the equation first, and then I'm just going to plug everything in. Okay, hopefully I'm going through this pretty quickly because you should have already done this yourself. You're just checking it over now. Okay, and then where's my decent calculator? I don't know. Oh, there it is. Hold on. Let me get my decent calculator that way. It's better to use an actual calculator, right, than your computer or your phone because easier not to make mistakes. Okay. All right. So then I'm just going to go ahead and plug all this into my fancy calculator. Negative 13.5 minus 18. Okay. Divided by 0.1 should be negative 167. Pretty close newtons. Okay. Right. And it makes sense that the force comes out negative, right? Because that would mean this way, right? Since to the right I said was positive. So that means my force on the ball has to act in the negative direction because it's turning that ball around. Okay. All right. If you don't get this number, be careful that you had this as a negative. Okay. That's kind of the biggest mistake. Okay. 4 kilogram cart has a forward velocity of 20 meters per second. Okay. A 60 Newton force acts upon it in the direction of motion. Whoops. I should say opposite. Upon it opposite the direction of motion. Okay, to bring it to rest. For how much time must the force act? Okay, so my initial velocity is going to be 20. We're going to say positive. My final velocity is going to be 0. This is coming to rest. Okay, the force is 60 newtons. The mass is 4 kilograms, and the time we do not know. Okay, so I'm going to go ahead and write my equation again. All right, so now look, now I'm looking for the time. Okay, so this is a touch trickier, right? So I need to multiply the time on both sides. Okay, so now I get Ft equals m Vf minus Vi. All right, and then I want to divide by force. Okay, so now I have T equals m Vf minus Vi over force. Okay, now I can go ahead and plug everything in. All right, so I'm going to have 4 kilograms times 0 minus, let's see, 20 meters per second, okay, divided by 60, okay, but look, do you see what's going to happen here? The time's going to come out negative, which it can't, okay? So here, look, I have to put a negative here because it says in the opposite direction, so that means whatever it is that's hitting it, right, is going to be facing opposite. So that to the right is positive, that force has to be negative 60. Okay, so that's going to be 4 times negative 20. So negative 80 over negative 60, which is going to be 8/6, or what is that, like 1 1/3? So 1.33 seconds because it's going to be time. Okay, so if it doesn't come out positive, right, your time has to be positive. If it doesn't come out positive, you probably missed this negative right there. Okay, so go back and fix that. Okay. All right, and I got to go fix that thing. All right, and then last one, a 3 kilogram object is moving forward with a speed of 6 meters per second. So let's just say it's like, I don't know, a cart or something. 6 meters per second. Okay, the object then encounters a force of 2.5 newtons for 8 seconds in the direction of its motion. Okay, so if to the right is positive, this force is also going to be positive. Okay. The initial velocity is 6 meters per second. The final velocity we don't know, and the mass is 3 kilograms. Okay, so I'm going to go ahead and write my equation again over T. All right, and now I'm looking to solve for VF. All right, so you don't have to do this, but it's good practice. Like if you think you're gonna, go into more advanced science studies, it's better to isolate your variable before, okay? So I'm gonna have m VF minus VI, okay? And then the next thing I need to move is the mass, so I'm gonna move the mass over here. So then I have Ft over m equals VF minus VI. Okay, and then if I add VI to both sides, right, then I end up with VF equals Ft over m plus VI, okay? And then I can just plug everything in, and everything's positive, so 2.5 newtons for 8 seconds, okay, divided by 3 kilograms plus 6, is that 6 or 8? Whoops, that doesn't look very good, 6 meters per second, okay? All right, so 2.5 times 8 is what, 4? No, 20. Oops, 20 divided by 3. Okay, so I'm going to have 6.7. That's going to be a meter per second. I know it's a little hard for you to tell with all these units, but that's okay. We're just going to go for it. 12.7 meters per second. Final velocity. Okay, and that makes sense, right? It's going to get faster because the force is in the same direction, right? So that's going to make it faster. Okay. All right, so check these. Make sure you can do these. You'll have to perform a calculation kind of like this on the final. Okay, so just make sure you kind of have a decent idea of how to do it. All right, and there it is like that. If you just want to kind of see the answer key, I'll put that up so you can pause it and just look at the answer key.